Young's double slit experiment. So Young's double slit experiment, it is very famously known as YDSE. So now what happens over here is you have a source of light and you have a small slits, two slits, and you have a screen over here. This is your capital D and this is your small d. Now this spherical wave, when they reach over here, it will form two wavefronts, and when they go, you have a dark band or a bright band. So what is happening over here? There is a alternate dark bands and bright bands due to the superposition of waves. Here one wave is behaving like a two different source because it is made to pass through the two slits or two small openings, and when the waves, whichever waves undergoes constructive interference will form a bright band, and whichever undergoes destructive interference, they will form a dark band. Remember, the thickness is same, and here the frequency is the necessary condition for interference is. So remember this points. The conditions for interference is the two waves should have almost same amplitude and almost same frequency, or you can say exactly same frequency or same amplitude or similar amplitudes. Same frequency is not possible using two sources, so we take one source and split it into two parts. Now using this, we have to find out one important thing, and that is called as the fringe width. So now we are finding out the fringe width, expression for fringe width. Now this is the slit, two slits, and this is the screen. This is capital D and this is small d. So this is the rays of light which is entering. Assume it is at the point P. They might be creating a constructive or destructive interference. It doesn't matter. Now I'll call this point as P, this as N, and these 2 points as AB. So now in the triangle, the first thing is the path difference is given by BP minus AP. What is the path difference? The extra distance traveled by the wave, and that is called as path difference. But that can be calculated using the two right angle triangles. So you will have it as, in the triangle APM, you will have it as AP square equals AM square plus MP square. So that is equal to capital D square plus, and if I assume from the center of the screen O, this distance is x, so you'll have it as x minus d by 2 the whole square. And from the triangle BPN, you will have it as BP square equals BN square plus NP square, which is equal to capital D square plus x plus d by 2 the whole square. So if you subtract these two, you will have it as BP square minus AP square equals, so d square will get cancelled, so you are left with x plus d by 2 the whole square minus of x minus d by 2 the whole square. This is of the form BP plus AP times BP minus AP, which is equal to 2xd. Now this is equal to 2d because if the point P is very close to O, the same distance, 2d into this is your delta, which is equal to 2xd. So from this you will have it as delta equals xd by d. So when you put the condition for the bright fringe, and for the bright fringe, what is the condition? Delta equals xd by capital D, which was the derived condition. For bright fringe, for a bright fringe, you will have it as xd by d is equal to, for the bright fringe, delta equals n lambda. So you'll have it as n lambda for nth fringe, or x equals n lambda capital D by small d for n plus 1th fringe. So for x plus nth 1th fringe, you will have it as n plus 1 times lambda d by d. If you subtract, you will get beta, which is equal to the fringe width, which is equal to lambda d by d. So this is the expression for fringe width, which you have to remember, students.